Welcome to today video lecture series in the topic of heat transfer. In heat transfer, in this class we will discuss about governing equations in Cartesian coordinates. So before we going to that, what is meant by a Cartesian coordinates? The direction is represented by x, y, z. This is called as a Cartesian coordinates. So here we consider is a rectangular section in the direction is x, y, z. So in a rectangular coordinate system, the temperature of a particular position within the medium is given by the direction is x, y, z with respect to the time t. So in this governing equation, the small element, the direction will be represented in dx in x direction and dy in y direction and dz in z direction. So here it is an amount of heat entering into the element in xy direction is represented by qx, qy and qz. So we know that in a Fourier heat conduction equation is qx is equal to minus ka dt by dx. So here it is represented is in the direction of x, the minus ka is the dt by dx, in the area will be represented is dy and dz. So similar for the direction is qy direction and qz direction. So the direction of qy heat transfer is similar from the z direction, minus k dt dy in dx and z, and also for the same as for qz is equal with represented by the area is in replacement of dx and dy. Amount of heat leaving from the element in xy direction, and the second part of the Cartesian coordinates is the amount of heat leaving from the element in xy z direction is qx plus dx and qy plus dy and qz plus dy. And we know that the Taylor expansion series is qx plus dx is we adding from that equation qx plus and dx is the represented the term of dou pi by dou x into dx, and qy for is dou pi y by dy into dy, and qz plus dz is equal to qz plus dou pi z by dou z into ds. So the amount of heat generated within the element is equal to q dot into the area is of the volume is dx, dy and dz. So where is the q dot is equal to rate of heat generated per unit volume. The amount of heat stored in the within the element. The next part is the amount of heat stored within the element is equal to rho c dou t by dou t in the volume of dx, dy and dz, where rho is a density of the material, c is a specific heat capacity of the material, and the dou t by dou t is a temperature change with respect to the time in the elemental volume. So the energy balance for the small elemental volume is given by is equal to, we are adding the previous two and the final one is heat energy conducted in the element plus heat energy generated in the element is equal to heat energy conducted out of the element plus heat energy stored in the element. So we are adding this equation with the representation of heat transfer is qx plus qy plus qz plus q dot dx dy dz is equal to qx plus dx plus qy plus dy and qz plus dy. In the term of rho c dou t by dou t in dx dy dz. So here is considered is an q dot is equal to heat stored in the element is equal to dou pi by x by qx and dou pi y by dou y and dou pi z plus rho c dou t by dou t. So here we substituting the equation is qx, we did wrote this in the previous equation is minus k dou t by dou x and dou t by dou y in the direction of z is dou t by dou z. So assuming this k is a constant, we represented that k into dou squared t by dx squared plus dou squared t by dou y squared plus dou squared t by dou z squared plus q dot is equal to rho c dou t by dou t. So in this term we represented as in the q dot is in the both side of the right hand side equation, the equation of simplify into the final stage. And the final equation of the heat conduction equation is dou squared T by dou x squared plus dou squared T by dou y squared plus dou squared T by dou z squared plus q dot by k is equal to 1 phi alpha dou T by dou T. So here is the alpha is thermal diffusivity. Alpha is equal to the unit is meter squared by second. So the final equation we consider into a assumption of the cases for a steady state. The right hand term will be in a 0 and steady state with heat generation is the middle term of q dot by k is will be a neglecting term, and 2D equation we consider the equation of x and y direction, and the one dimensional equation we consider z direction. So this is the equation of heat conductor general equation in Cartesian coordinates.